All right, so for the quiz and eventually the test, this is basically the information you need to know so far. So know that to use a normal CDF, you have to put in a lower bound and upper bound, the mean and the standard deviation. So you would set it up like this in your calculator. This is also your work, so make sure you are writing what you're putting in the calculator. And remember, you use this when you want a percent, percentile, probability, proportion, or the area under the curve. So this is what you use when you want those things. Now, if you have one of those things, let's say you have the percentile or you have the probability, then you want to use inverse norm. And remember, inverse norm is always the percent to the left, and it's as a decimal. So you can't put in your calculator 95. You have to put in 0.95. And then if it says 68% is above, then you need to change it to the percent to the left. So you basically just do 100 minus 68, and that'll tell you the percent to the left that you'll actually end up putting in the calculator. And then your z-score formula, that is when you have 3 of these things that are in the formula, and you need one of them. So the z-score is one of those things, the value, the mean, and the standard deviation. So if you're missing one, but you have the other 3, then you could use this formula. And there's 2 examples here on the right and the left, so feel free to screenshot this page if you need it. But I'm going to go back and we're going to work on some of the problems that are on this practice sheet. So first, the question number 1 is asking for the percentile a z-score of 2.3 has. So basically, we're looking for the percentile. So if we look at the page, the last page I have here, if we want the percentile, we are going to use normal CDF because we want the percentile. So we then got to just go back and figure out, okay, what are we putting in those spaces for lower bound, upper bound, etc. So we know we're using normal CDF. Remember, this work is what you need to show. And our lower bound, well, if we're talking about a percentile, percentile is always to the left. And so we want negative infinity. And our z-score is 2.3. So we're basically saying everything to the left of 2.3. And then our mean for a z-score, we should all know, is 0. And our standard deviation is 1. So remember, that's the default mean for and standard deviation for a z-score. Anytime when we're talking about a z-score or standard normal curve, that is what we use, 0 and 1. So now you would put that in your calculator. So I do not have a live screen calculator, but I'll go ahead and point to what you should be hitting. So you should hit second and then vars, because distribution is what we're getting to. And then you'll look in your screen and you should see normal CDF, and then you're going to enter your different things, your lower bound, upper bound, mean, and standard deviation. And then you'll paste it and then hit enter and you'll get an answer. So I get 0.989, or if I round it to 2 decimal places, it'd be 0.99. That's an 8, terrible 8. All right, so a few things. If you don't know how to put this little E in the calculator, you should notice there's a double E right above the comma. So above the comma key. So you have to hit second and then the comma in order to get that E there. It has to be that E. Another thing is, if it's the percentile, or if it tells you less than or lower than or below, any of those words that hint towards the left, then you're going to use negative infinity as your lower bound. And then anytime you use negative infinity, that's going to be your lower bound. If you had to use upper or positive infinity, you were going to put positive infinity in your upper bound, because positive infinity is the highest thing you can get, so it's always going to be your upper bound. So anytime you use negative infinity, make sure it's in your lower bound. Anytime you use positive infinity, make sure it's in your upper bound. Alright, so for number 2, this one's asking a very similar question. So if you have a z-score of negative 1.36, we're trying to figure out what percentile it's at. So same thing, it's just asking in a different way. We're still looking for a percentile. So we're going to use normal CDF, just like we did before. And we know we're looking for a percentile, which is already the percent to the left. That is supposed to be a 1, but I'll do it over. So our lower bound's still negative infinity since we're talking about a percentile, which is already to the left. Our upper bound is the z-score, and then the mean and the standard deviation for a z-score. So that is approximately 0.0869. So if we're rounding to, let's say, 2 decimal places. So that means you want to cut it off there. This number would then tell you to round this up. So it'd be 0.09 if you're asked to round to 2 decimal places. 3 decimal places would have been 0.087 since you would have cut off here, and that 9 would have rounded the 6 up to a 7. So as long as you round appropriately, 2 to 3 decimal places should be fine. All right, number 3, what proportion? So once again, you're asked for one of the P words. If we go to our little graphic organizer here, we're asked what proportion. So still, we want a proportion. So we're still using normal CDF. So if you get these problems, just go through and check your answers, pause and play. That way you don't have to sit here and watch me write all these, but if it helps you, we are doing the normal CDF. What proportion is less than a z-score of negative 1.58? So once again, it's less than, so I'm still using my negative infinity. Negative 1.58 is my upper bound, and it's still a z-score, so we're still using 0 and 1 for the mean and standard deviation. And the answer should be 0.057. So I'll just stop it there. That's 3 decimal places, so about 5 point something %. So all these things should make somewhat of sense if you actually drew a curve. And I'm just going to sidetrack really quick in case this was a quiz and you wanted to make sure your answer makes sense. Remember, the standard deviations are the z-scores. So basically how far a value is from the mean is what z-scores represent. So we only go at about 3 to each side. So if, for instance, I was going to graph the z-score that we had in the last problem, negative 1.58, that's going to be a little bit more than negative 1.5. And what is a probability or a proportion less than that? So basically we're trying to figure out what percent of the curve is shaded there. So that does make sense to be, since it's tailing off here, it's a really small portion, to be about 5.7%. Makes sense. Now, if for some reason you shaded and your value is almost the entire graph, then you would know 5.7% wouldn't make sense. So maybe you would then know, okay, well, I must have went the wrong way or put the wrong infinity in the calculator or something like that. So using a graph to just make sure your answer makes sense is probably a good idea on the quiz or the test. All right, so for the next problem, what's the probability? So once again, I'm using normal CDF because I'm looking for one of the P words. And we're looking for the probability the z-score is greater than 0.93. So greater than. Basically, the 0.93 is now our lower bound. Since it's greater than, we're dealing with positive infinity. And remember, whenever you're dealing with positive infinity, it goes in the upper bound. And 0 and 1 is our mean and standard deviation for all z-scores. So now if I put that in the calculator, I should get 0.176 if I just go out 3 decimal places, and remember as 2 decimal places, I'd be cutting that off there, so this would round this up to an 8, so it'd be 0.18 to 2 decimal places. Once again, 3 or 2 is perfectly fine. I'll take either one. All right, number 5, ask for what proportion. So once again, I'm still dealing with normal CDF. Okay, of area, so still normal CDF. Once again, if you look at our chart there, that is dealing with the area under the curve. It's dealing with percent, probability, proportion. All right, so going back to the problem, we have a z-score. We're looking for it between these 2 values. So that's your lower and your upper bound. No tricks there. They give you both values. Your mean is still 0. 1 is still your standard deviation since we're still doing with z-scores. And if you put that in your calculator with your lower and your upper bound, you should get approximately 0.858, but I'm going to round that up to a 9, or you could do 0.86. So that's how much of the curve should be shaded if you shaded in between those 2 z-scores. All right, so number 6 is just a different format of asking the question. Instead of asking it in words, just asking it in symbols. So you got to know what these symbols mean. Remember, you can look at P as percent, probability, proportion, any that you prefer. It's all of our P's. so that a z is less than. Remember, this is less than. Some people think it points in the direction of what values it wants. Sure, think of it like that if you like. So basically, we're going from negative infinity, since that's to the left, to our upper bound is going to be 2.89. And once again, since we're finding one of the p's, we're going to use normal CDF. And our lower bound's negative infinity. Upper bound is 2.89. Mean standard deviation. So our answer should be, if we put in the calculator, is 0.998. And this makes somewhat of a, it makes sense, not somewhat sense, but if you graph the curve, it does make sense, because remember our z-scores, we only could see about 3 without zooming in. So basically, if you plotted 2.89, that's almost at 3, and that's almost everything to the left of that is almost the entire curve shaded. So it makes sense that it's about 99.8% of the graph shaded. Makes sense. So that was number 6. All right, moving on. We already did 6 on the other page. So this one, if I set it up, remember we're still looking for a percent, probability, etc. So we're still using normal, CDF, but now it's greater than. So if you look at that as an arrow, it's pointing to the right. So we're going to use positive infinity, because positive infinity is to the right, but remember, anytime you use it, it's going to be in your upper bound, and your z-score is going to go in your lower bound, and 0 and 1. So when we figure out what percent of the graph is to the right of the z-score, negative 2.25, you should get approximately 0.98777, so we'll just say 0.988. So once again, that's a large portion of the graph shaded, because we're graphing down at negative 2.25, which is somewhere down there, and the greater than side of that. So that's going to be a huge part of the curve shaded. All right, so number 8, once again, probability, percent, percentile, all those p's, we're going to use normal CDF. And we are given 2 z-scores that it's in between. Remember that this just means in between negative 2.25 and 1.77. So we can go ahead and write those as our lower bound and our upper bound. Mean is still 0, standard deviation is still 1. So that's approximately 0.949. So that's another large portion of the graph shaded if you were to draw the curve and shade between those 2 z-scores. All right, so number 9, it's a little different. It says find the z-score. So now we're not finding one of the p-words or the area. We're not finding one of those. We are given percentile, percentage. So looking at our sheet here, or my cheat sheet, this is now we have the percentage. We have the percentage. So we're using inverse norm. And remember, the setup for inverse norm is the percent to the left, comma the mean, comma the standard deviation. So wherever that is, right here, we are going to use inverse norm. And the lower 45.2%, well, that's already to the left if it's lower, so we're going to leave it as 0.452, comma the mean for a z-score, remember, is 0, standard deviation is 1. So now if we use inverse norm, same place we went before, which is second vars. Right below normal CDF is inverse norm, and we're putting in 0.452. Remember, you have to put it in as a decimal. It will not take it otherwise. And you should get that that is a z-score of negative 0.121 if we round to 3 decimal places. So it's basically that z-score, if you were to graph it on the curve, it's a terrible curve, but yeah. All right, so if we were to graph negative 0.12, that's basically barely off of 0, but on the negative side. And it's cutting off the lower, so basically everything's shaded this way, is about 45.2%. That makes sense because anything from the middle over would have been 50%, but it's a little less than that. So it does make sense. All right, number 10. So now it says find the z-score that cuts off the upper 18%. So we have a percentage. So if we have the percentage, we're using inverse norm. and we're putting in, now it does say upper, so I was working so fast I didn't even read. Don't do that. Make sure y'all read upper 18.3%. So remember, that's to the right. But notice in our little note sheet here is that you have to put in the percent to the left. So if we know that 18.3% is to the right, is the upper, then we can just subtract from 100 and that'll give us the percent to the left, which is 81.7. So 81.7% would be to the left. So we have to put in 0.817, comma, the mean and the standard deviation. And we can go ahead and put that in and see what we get. So I get a z-score of 0.904. We'll cut off the upper 18.3%. All right, moving right along. Number 11. So here we're asked who scored the highest, and we're given a table. We have 3 names, and we have John, Amy, and Pete. So first it says find the z-scores for each. So it gives us the mean, and it gives us the standard deviation. Now, it didn't give us a percentage, so we're not dealing with inverse normal, normal CDF. We're finding a z-score, so that is going to be in the bottom here, where it says we have the value, the mean, standard deviation, or a z-score. We have to have 3 of these things here, and we're only missing 1. So we're looking for the actual z-score, so we're going to leave z blank in that formula. So I'm just going to write the formula over here since I'm going to use it a few different times. So remember, it's the value minus the mean divided by the standard deviation. So we can do this for each of the people here. So I'm going to first do it for John. So his z-score, well, we have his value that he scored on his actual test. He had a 540. Now he took the SAT math section, so we're dealing with this data here. So the mean is 500 divided by the standard deviation, which is 100. And if we do that math in the calculator, we get that John has a z-score of 0.4. So he scored 0.4 standard deviations above the mean. Now we can do Amy now. So Amy, her z-score, well, she got a 25 on the ACT math, so that is using this data. So the mean for that test was an 18, standard deviation was a 6. So her z-score is 1.1, if you round, 17. So she scored 1.17 standard deviations above the mean. So she actually has done better than John so far because he didn't even score 1 standard deviation above the mean. And then our last person to do is Pete. So Pete, his z-score, well, he took the ACT math, so he got a 21. And the ACT math, once again, has that's a terrible arrow, but has a mean of 18, a standard deviation of 6. So his z-score is 0.5. So basically, Pete did better than John because he scored a half standard deviation above the mean, and John didn't score a half. He scored less than half. But overall, Amy did best because she scored more standard deviations above the mean than anybody. All right, so part B, well, that's actually answering part C right there. Who scored the highest? We know that Amy did. All right, but anyways, let's go to part B, find the percentiles. So here we're asked to find percentile. So remember that is, if we're looking for a percentile, we are using normal CDF. So we're going to use normal CDF for each of these. And I'm going to first do John. So we're going to use normal CDF. And we're going to put in, remember, percentiles always to the left. So we're going to put in negative infinity, and his z-score is 0.4. His standard deviation is 0, and his, for a z-score, the mean is a 0, and standard deviation is 1. So excuse me, I said 0 for a standard deviation. But now, well, there's another way to do this. If you really wanted to put in his score, you could have put in negative infinity, his actual score, which was 540, the mean for that test, which was 500, and the standard deviation 100. Either one of these should give you the same answer. One might be rounded slightly different, but they should give you the same answer. So either way you do it, you should get that John has a percentile of approximately 0.655. So basically, as a percentage, he scored better than about 65.5% of his peers on that test. So not too bad, John. All right, so the next one is Amy. For Amy, we're going to use normal CDF. Since I found her z-score, I'm just going to go ahead and use it. But once again, it is rounded, so if you use the actual test score she got with the test mean and the test standard deviation, you'll probably get a little bit more accurate answer, but they'll be very close. So if I do this, we should get that Amy's percentile is about 0.879. So she scored better than 87.9% of her peers, which is really good. And then lastly, we have Pete. So Pete, we're going to use normal CDF. Look, I noticed that I left off my F there. All right, so normal CDF. And once again, I'm going to use his z-score, but you could use his test score if you want. Oh, I'm writing so fast, I realized here I also forgot my negative infinity. Hopefully y'all caught that, because I was about to do it again. Okay, so negative infinity. His z-score, Pete's z-score is 0.5, standard deviation 0.1. So once again, if you used his actual score, it'll be very, very, very close, but slightly off because we rounded his z-score. So his percentile is at 0.691. So basically, Pete scored better than 69.1% of his peers. So, like you could see here again, he did a little bit better than John, but Amy did better than everybody. So that is our answer for C, that Amy scored the highest. So for number 12, here we are given a situation where we have some random variable x. We don't know if it's heights, we don't know if it's scores, but they just said, we have some random variable that's normally distributed, so we know it follows a bell curve shape. It has a mean of 25.6, a standard deviation of 5.1. So we want to find the z-score for an x value of 34.7. So if we look at what we are looking for, we're trying to find a z-score, so we're going to use our z-score formula. Since we have the mean, we have the value, and we have the standard deviation, we have the three other pieces we need. So the x value that we have is 34.7, the mean is 25.6, and the standard deviation is 5.1. So we just punch that in, see what we get. So I get a z-score of 1.78 if I round to 2 decimal places. So that's the z-score that corresponds to that x value. So the next one asks for a z-score that corresponds to an x value of 13.4. So once again, we're finding the z-score. So I'm going to use the same method because I'm leaving z blank, or leaving it as a variable, since we don't know it. But we do know the value, we know the mean, and we know the standard deviation. So I get that the z-score is approximately negative 2.39. So basically, we know that the value is below the mean since it's negative, which makes sense. The value, 13.4, is below the mean of 25.6. So it makes sense that it's negative. All right, so now this one, we're finding the x value that has a z-score of negative 3.6. Now we're looking for the x value. We have the z-score. So we're putting this number where the z goes. So negative 3.6 is the z. We don't know the x because that's what we're finding. And we have the mean still. And we have the standard deviation. So here's one like the example I put on the page where you're having to, not that side, but this side, where you're having to work backwards. So you're having to undo what's being done. You know the z-score, you're looking for the value. So the first thing we're going to do is we're going to undo the 5.1 by multiplying by 5.1. So remember, the line means dividing. So if you're dividing by 5.1, the inverse is to multiply. And we get rid of our 5.1s, and we can multiply these two. And we get, that is negative 18.36. Now that's equal to x minus 25.6, because we bring down anything we haven't used. And now we're just going to go ahead and add that 25.6 to both sides, just like we would if we were just solving an equation in algebra. And now we get x's by itself. So we have x is equal to 7.24. So that's the x value that has a z-score of negative 3.6. So x equals 7.24. All right, so for letter D, very similar. You have the z-score. You're looking for the x value. So I'm going to put the 2.9 where the z goes. I'm going to put x where x goes. Mean is 25.6. Standard deviation is 5.1. So just as before, we're going to get rid of the 5.1 so that you can go up there and work where that x is. So if we do that, we have 5.1 times 2.9, and that gives us 14.79 equal to. All right, and then if we go ahead and add 25.6 to both sides of the equation, we will get our x by itself. So we have x is equal to 40.39. So the x value that has a z-score of 2.9 is 40.39. All right, so now number 13. So we have the situation, talks about Tiger Woods and his range, basically. So the distance that's traveled by his golf ball is following a normal distribution. It has a mean of 304 yards and a standard deviation of 8 yards. So we're going to find the proportion. So right there, you should know, if you're looking for a proportion, that you are using, we want the proportion, so you're using normal CDF. So we are trying to figure out what's the proportion of time or proportion of hits that are going to land between 296 and 320 yards. So right there, remember, we're finding the proportion, so we already know we're using normal CDF. And they just gave us a lower bound and an upper bound. So 296 is our lower, 320 is our upper. Our mean is given to us in the problem is 304, and our standard deviation is 8. So if we see what that equals, we get 0. 0.81, if we round that 9. So about 81.9% of the time, his golf ball will land between 296 and 320 yards away. So letter B says label the axis appropriately on each mark based on our letter part A. So basically, we know the mean goes in the middle. That's 304. Remember, you add the standard deviation to go this way, and we subtract the standard deviation to go that way. So if we add, our standard deviation is 8. Remember, standard deviation is 8. So if we add 8 to 304, you get 312. And then if you add 8 to that, you get 320. And then if you add the 8 to that, we get 328. So now if we start back in the middle, where our mean is, and we subtract 8, we get 296, right? Yeah. And then we subtract again, we get 288, and if we subtract again, we get 280. So basically, they want us to shade the area. Well, we know we're going from the lower bound of 296, and our upper bound of 320. So that's right on the lines. And we're shading the area in between those two lines. So basically that looks like it's 81.9% based on our calculations in Part A. All right, so Part C says what percent of his golf balls will travel less than 280 yards. So remember, less than, and we're looking for a percent. What percent? So right there we know we're using normal CDF. Less than's to the left, so we already know we're using negative infinity as our lower bound. Our upper bound is 280, and our mean for the problem is 304. We're not dealing with z-scores, so you're not using 0 and 1. We're using the mean and the standard deviation from the problem. And if we put that in the calculator, we get 0.0013. So basically, if we look at that as a percent, that's that's moving the decimal over twice or multiplying by 100, 13%. That's not even 1 whole percent. So basically, based on our data, his golf balls are basically going to always travel longer than 280 yards. It's less than 1% of the time where it's going to be less than that. All right, so Part D, what proportion? So once again, what proportion? That's one of our P words. We're using normal CDF again. Well, we're trying to figure out when they travel further than 325. So further than would be to the right. So that's our positive infinity. And remember, whenever you use positive infinity, you're putting that as your upper bound. And then your lower bound is the actual value. So then we have our mean is 304 still. Our standard deviation is 8. That's a terrible 8, but that's an 8. So that gives us 0.004. So basically less than 1% of the time, it's going to go further than 325 yards. So yeah, less than 1%. So, and they said, what's the proportion? So you can leave it as a decimal. All right, last problem, number 14. So we have the average performance of females on the SAT, especially in the math section, is lower than males. The reason's controversial. In 2007, female scores on the ACT math test followed a normal distribution with a mean of 500. We need that. Standard deviation of 111. Male scores had a mean of 533 and a standard deviation of 118. So what's the probability? Well, right there, I already know what I'm using, normal CDF. Of a female scored, or that a female scored above, so I know that's to the right. So right there, I know my upper bound is positive infinity without even reading any further. The male average. Well, if they're scoring above the male average is 533. So that's my other bound. And we're looking at females. So make sure you use the female mean and the female standard deviation. So the female mean is, 500. And the female standard deviation was 111. So now, if we see what that equals, we get 0.383. So basically about 38% of females will score above the male average. So, all right, moving on to letter B, the last one. Find the 85th percentile. We have the percentile. We have it. It's 85. So if we have it, we're trying to figure out what score is going to give us 85% below that number. So percentile, remember, is already to the left. So we're going to use inverse norm because we have the number, or the percentile. You have to put in the percent to the left, which percentile already is. And this is for males. So we're going to use our male mean, which is 533, and our male standard deviation, which is 118. So when we do that, we get 655.5 Let's go with 0.3. We'll round it to 1 decimal place. So basically, a male would have to score 655, or around about there, on the math SAT in order to be at the 85th percentile, in order to score better than 85% of other males. Okay, that's it. So hopefully you guys study, get ready for the quiz, because, yeah, y'all gotta pass. Adios.